Number 3 on the 2026 AIME I problem. A hemisphere with radius 200 sits on top of a horizontal circular disk with radius 200, and the hemisphere and disk have the same center. Let T be the region of points P in the disk such that a sphere of radius 42 can be placed on top of the disk at P and lie completely inside the hemisphere. The area of T is divided by the area of the disk is P over Q, where P and Q are relatively prime positive integers. Find P plus Q. So a hemisphere with radius 200 sits on top of a horizontal circular disk with radius 200. So since 3D is hard, let's just cut it in half and see it as 2D. The radius is 200 here, and radius 40 sphere sits inside. So this should be the outer boundary of the area, like this. From here to here. Now this length is 42, and this length is also 42, and this length is 200 minus 42, so it's 158. Therefore, this length, or the radius of this region of points P, is 158 squared minus 42 squared to the square root. Since these numbers are so big, let's just scale it down and then scale it back up. Scale it by 221/79. Now 79 squared minus 21 squared is 6400 minus 160 plus 1 minus 441, and that is equal to 6401 minus 5601, and that is equal to 5800. Now we gotta multiply by multiply by 4, since it's a square and 2 to the square is 4, so 23200. So this length over here, this radius, is equal to square root of 23200, and that is equal to 20 square root of 58. So, actually we don't even need to calculate this, since the area, we only need the area, so it's 23200 pi. And the area of the disk itself is 40000 pi. So we divided 23200 by 40000, and this is equal to 232 divided by 400, and this is equal to 116 divided by 200, again equal to 58 divided by 100, and this is equal to 29/50. So the answer is P plus Q, so 79.